Hey guys, you caught me in the middle of an experiment. When you were a kid, how many of you went outside and made things on your own and you had to come up with your own way of doing things? Well, growing up, we didn't have all the technology and stuff that you did, so we did have to come up with our own way of doing things. So we would make volcanoes. That was the one thing I remember doing. And how we got the volcano to erupt and have all the lava, because we did have that. We built our volcano out of dirt, and we used vinegar, and I have white distilled vinegar in my container, and we used a little bit of baking soda. And as you can see, it causes the bubbles and it would overflow. Depending on how much vinegar you put in there and how much baking soda you already had in there. So this is sodium bicarbonate, and we mixed it with the acid. So we had a chemical reaction. So that's what we're studying this week is chemistry. And you may be saying, well, I'm never going to mix vinegar and baking soda to be doing somebody's hair. You'd be surprised at how many people will put vinegar on their hair to make it softer because they may have used a lot of high alkalinity on their hair, and so they're going to use this vinegar to bring it back to that pH. And we will talk about the pH scale in the classroom during this time when we're studying this. Baking soda. We're not going to use baking soda, are we? Well, we just might. Baking soda, back in the day when we wanted our hair to be high, we would have to use baking soda and water mixed in our shampoo, or I did at least, to get the rave hairspray that we used off of our hair because we had so much hairspray buildup on our hair from teasing it up and spraying. We're the reason there's no ozone layer, okay? Back in the 90s, that was us, okay? So we're going to move this out of our way and we're going to talk about some more stuff. So I want to explain chemistry a little bit. So chemistry, along with chemicals and chemical changes, makes life on Earth possible. The daily function of our bodies is based on chemical reaction, and our very hair, skin, and nails are made of chemicals. Creams, lotions, masks, and makeup, whether they come from natural sources like plant extract or from ingredients manufactured in a laboratory, are made of chemicals. The effects of cosmetics and beauty products are based on how the body reacts to chemicals. Beauty professionals must have a basic knowledge of chemistry to understand how different chemicals affect the hair, skin, and nails, and be able to choose the correct products for each client's particular needs. Now, we've already talked about the structure of hair, so you know that all products are not for all types of hair. And I'm sorry there's a glare on my glasses. I tried to get rid of it. I might can shut another blind. But we need to figure out what kind of chemical we need to use. If we're doing a relaxer on someone, or a chemical wave, or a color, or highlight, what product do we use on them? We need to find out. So you're thinking to yourself, well, I never said I was going to be a chemist. I wanted to be a hairstylist. But have you ever thought about possibly making your own hair product? All right. So let's identify the basics of chemistry. Chemistry is a science that deals with the composition, structures, and the properties of matter and how matter changes under different conditions. Now, I do hope you're following me along in the book, okay? Matter is any substance that occupies space and has mass, which is weight. I am matter. Right now, I'm a lot of matter, and I hope to be losing a lot of my matter soon, okay? Since matter is made from chemicals, everything made of matter is a chemical. Everything known to exist in the universe is made up of either matter or energy. There are no exceptions. Energy does not occupy space or have mass. Now, sometimes I have a lot of energy and sometimes I don't. All right, element. let's talk about the elements for a minute. And I do want to get my book out. And so this week we are in our black book, and it is chapter F6 in our black book. And on page 155, you will see this symbol. Okay? The top number is a 6. It is the atomic number. Then you have the name, which is carbon, down at the bottom, down here. And you have the symbol, which is a C, and the atomic mass is underneath it. Now, an element cannot be reduced. It is the simplest form of a chemical matter. It cannot be broken down into a simpler substance without loss of identity. Meaning, if you take anything away from this, it's going to lose its identity from what it is. If you take one little atomic mass out of this, it is no longer carbon, okay? So all matter in the universe is made up of these elements, and they have their own distinct physical and chemical properties. If you take one thing away from me, then I'm not going to be Carol Johnson anymore, right? Well, if you take some weight from me, I'm still going to be Carol Johnson. I'm just going to be a little bit smaller. But if you take chocolate out of chocolate chip cookies, are they still chocolate chip cookies? No, they're just a cookie, okay? So each element is identified by a letter symbol such as O for oxygen, C for carbon, H for hydrogen, N for nitrogen, and S for sulfur. Composed of a single part of a unit, cannot be reduced to a simpler substance without loss of identity. 118 known elements and 98 naturally occurring elements. Now I'm going to move this vinegar because I can smell it really good right now. And so what happens when you smell a lot of chemicals a lot? You may get sick from them, right? All right, and I do not want to get sick. All right, atoms. Let's talk about the atoms. This is a basic unit of matter. With a nucleus at the center surrounded by negatively charged electrons that move around the nucleus in orbit. The nucleus consists of protons, which are substance particles with a positive charge, and neutrons, subatomic particles with no charge, and the number of protons determines the element. And you will find that on page 156, okay? Right in here. The atoms cannot be divided into simpler substances by ordinary chemical means. Okay? Molecules, which is on page 157. Molecules is a chemical combination of two or more atoms in definite fixed proportions. For example, water is made from hydrogen and oxygen. A chemical combination of atoms is an elemental molecule, and it's the same element in fixed proportions. The air we breathe is an element molecule, O2. The ozone in the atmosphere is an element molecule, O3. The compound molecule, these are the chemical compounds of two or more atoms of different elements in fixed proportions. Sodium chloride, NaCl, or common table salt, is a compound molecule that contains one atom of sodium, Na, and one atom of chlorine, Ci. All right. Also on page 157, you are going to find right here at the bottom of the page the physical and chemical properties of water. Now, when my son was in 3rd grade, he learned a little rhyme. It was, it comes down in the form of, how was it? Something that comes down in the form of precipitation goes up as condensation, and just water keeps making its round, okay? So physical matter and changes, matter can be changed in two different ways. Physical forces cause physical change and chemical reactions cause chemical changes. A physical change changes the form without forming a new substance. So water can be changed into ice. It can be changed into this cup, this bottle, this beaker. It can be changed into many different sizes, shapes, or forms, but it's still water. Okay? And it melts and becomes water again. Or you can boil it and it evaporates and becomes steam. A chemical change is a change in a substance chemical composition. A change creates new substances with different properties. For example, iron to rust, wood to ashes, the oxidation of hair color, or the polymerization of artificial nail enhancements. Okay, physical and chemical properties of matter. And it's on page 158. Physical properties are characteristics that can be determined without a chemical reaction and that do not involve a chemical change in the substance, include color, solubility, odor, density, melting point, boiling point, hardness, and glossiness. Chemical properties are characteristics that can be determined only by a chemical reaction and a chemical change in the substance. Examples include the ability of iron to rust, wood to burn, hair to change color through the use of hair color and hydrogen peroxide. Okay, so now we have a pure substance and physical mixture. Right here at the top of page 159. And I want you to take a good look at it and follow me along. So I really, really hope you're following along in this video. Okay? So a pure substance is a chemical combination of a matter in definite fixed proportion. Pure substances have unique properties. Water and salt are examples of pure substances. With atoms in set proportion, 2 hydrogen atoms per oxygen atom, H2O, and 1 sodium atom per chlorine atom, NaCl, respectively. Physical mixtures, physical combination of matter in any proportion. The properties of a physical mixture are the combined properties of the substances in a matter mixture. Salt water is a physical mixture of the salt and water in any proportion. Pure substances, a chemical combination of matter in definite fixed proportions. Pure substances have unique properties. Water and salt are examples of pure substances with atoms in set proportions. 2 hydrogen, again, per oxygen atom, H2O, and 1 sodium atom per chlorine atom, NaCl, respectively. Physical mixtures, physical combination of matter in any proportion. The properties of a physical mixture are the combined properties of the substance and mixture. Salt water is a physical mixture of salt and water in any proportion. Okay, so this is my next example I want to show you. And I hope you can see it. I'll move it up closer to you, and I may cut on one light. Okay, so we're going to use the little beakers. And in this first one, I'm going to pour some water. I'm going to pour 100 milliliters of water in this beaker. And I have some oil. Has anybody ever heard the term oil and water do not mix? Well, here's our example right here. I can stir, 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 and I'm going to bring it up closer to you. And I will show you this again in class. And I hope you can see that no matter what, the oil is going to sit on top of the water and it's not going to distribute into it. Now, let's try it with some oil in the bottom of the beaker first. And now let's put some water in it. And you can really see how the oil and water has separated right here. And I put a little too much water in there because the water should have sat on top of the oil, because even though you would think the oil would sit on top, if you don't put enough water in there, it will sit on top of the oil. Okay? And again, I will show you this again in class. Now, again, you're thinking, all right, I'm not going to be in a salon mixing up oil and water. Why do I have to know this? All right, for one thing, you have to know it because it's in the book. All right, for another, they would not put it in the book if it was not important. So let's talk about our products. We have a relaxer. This relaxer is resistant relaxer, which means it is strong. All right. We have developer. We have Marbicide, but we clean with. Ship shape. We have disinfectant spray. Cool care. Glass cleaner. And we have some regular old Comet. Okay. All right. Now, this has to be stored properly, and as you can see, I still have on my gloves because there could be some relaxer on the outside of this container, and I do not want it on my hands because it could irritate my skin, especially if I didn't know it was on my hands and I didn't wash it off quickly. Now, if someone had this on and we did not clean those shampoo bowls, you know, we're always asking you, did you clean the shampoo bowls? How long did you let it sit there? What is the contact time if we spray this on there? 10 minutes. What is the contact time if we use a barbicide wipe? 2 minutes. What is the contact time that we let these sit in there and clean? 5 minutes. This is a cleaner, this is a disinfectant. All right, so if we don't clean and disinfect and somebody has had a relaxer on their hair and they did not clean, you can't see it, it's dried in. Well, Miss Mary just went and got her highlight. She's got bleach with 40 volume developer on her. She goes and leans back in that shampoo bowl and she's getting that relaxed, that bleach out, and she's getting shampooed. Well, when she gets back to the chair, she's like, burns a little bit, and the stylist says, well, it's probably just, let me check and make sure there's no bleach. No, there's no bleach. It might just be where the bleach was, but there's no bleach on you. Week later, Miss Mary has to go to the doctor because now she is very irritated and got broken skin because she's had a chemical reaction from these two. Okay, that's why it's so important. All right, now, so we know how to clean our sinks. That's the reason why I'm going to stay on you, why Miss Tiffany and Miss Devin are going to stay on you, and any other instructor you have. How should we store these? Should these be stored with the cleaning products? No. These should be stored in their own area, and you should go by what it says. It says, keep out of reach of children. If this product comes in contact with eyes, ears, or mouth, flush with cold water and consult a physician immediately. This is also in our SDS. You will find that in case it does come in contact. All right, so if I've just finished using my shears or my clippers and I want to clean them, I'm not paying attention. I'm talking and having me a good time, and I pick up the glass cleaner because it's down there with the Cool Care. So is the disinfectant, and I spray the glass cleaner on there. What's going to happen? Well, it's not going to streak them. It's not going to have a film on them. They will get clean and they will have a fresh scent, but they will not be disinfected. They will not be lubricated, and they could rust because I wasn't paying attention and I did not grab the correct one. So this needs to be in its own cabinet, and I need to get the Cool Care. The disinfectant spray, it may not hurt my clippers as bad as the glass cleaner, but I don't want to use this either. This is for the air, okay? This is for my clippers because this says coolant, disinfectant, lubricant, cleaner, and rust prevention. This says kills most germs, eliminates odors, prevents mold and mildew, okay? Now, I need to make sure I use this in the proper way. There is a list of how to measure it out. I have looked on the back and made it simple for you. A lot of you have said, I'm not good at math. It's not hard to do that. The measuring cups and the teaspoons and tablespoons are in here. Same goes for the ship shape. But what if I picked up the cleanser instead? What's going to happen? Same mistake goes with this. So we always need to be paying attention, and we always need our gloves on when we're using our cleaning supplies. And you may ask why. And just like when you're doing your chemical wave, well, people don't use that in the salons, or I never see people doing this when I'm in the salon. Maybe you should start questioning why they're not doing it, okay? Now I can take my gloves off, but what do I need to do? I need to sanitize my hands, okay? Unless I go to the sink and wash them. Okay, let's see if there's anything else, because like I said, we are going to go over the pH chart when we're in class, and you will find that on page 166. So if you have any questions about anything that you're using, look it up online and see if you can find what the pH is on that product. If you have any problems with it, bring it to me and let's find it out together and see if we can find out if it's an acid, close to the acid side of the pH scale, or the alkali pH side of the scale, okay? All right, let's see what else we're going to look at right this second. We've already talked about practicing chemical safety and how to store them, the SDS sheets. What else could this jug look like if I had it turned around this way? It would look like a bottle of bleach, right? So make sure your stuff is labeled with the correct label. This has to have the manufacturer's label on it, as well as all of this too, okay? You also need to know how to dispose of certain products because it could hurt your drain if you pour them down your drain, okay? Now, when this video is over, I want you to answer your check-in questions, and as you always do, put them in the box below. And I hope you enjoyed this video better than you did just sitting there watching a PowerPoint. If you did, just let me know so I can continue doing them. Thanks.